says that find the nth derivative. Find the nth derivative. Given that y is equal to x cubed multiplying exponential 2x. Question says that find the nth derivative, right? By nth derivative, we've seen the derivation previously. Meaning, first thing first, say you want to find the nth derivative of any given question, write out the general formula for the nth derivative, right? And we've seen that given that y is equals to uv, right? We want to find the nth derivative, meaning y is power of n. You can write this as y is equals to u plus v all raised power of n, where the nth derivative becomes what? U all raised power of n multiplying v plus n multiplying what? U raised to the power of n minus 1 v raised to the power of 1, right? Plus n all into bracket n minus 1 all divided by 2 times 1 multiplying u raised to the power of n minus 2 multiplying v raised to the power of 2, right? Plus n all into bracket n minus 1 open bracket n minus 2 all divided by 3 times 2 times 1, right? Multiplying u all raised to the power of n minus 3 multiplying v all raised to the power of 3. Now, we want to find the nth derivative of this question. You need your u and you need your v. You need your u and you need your v. Just like the way we normally do in differentiation and integration. Identify your u and identify your v, right? But you observe that this general solution for the nth derivative, the power of u is in terms of what? N. Meaning the power of u is expressed in terms of n, while the power of v is expressed in terms of real number. Meaning this is v function, this is the first derivative, this is the second derivative, this is the third derivative. Continuously you have your fourth derivative. So what it means that your v, in this case, you always differentiate your v with respect to the derivative. Meaning you find the first derivative, second derivative, third derivative, fourth derivative, fifth derivative, right? But your u, you find the derivative where the power of the derivative is expressed in terms of n. Where the power of the derivative is expressed in terms of n, right? But the question now is, what is my u, what is my v? What is my u, what is my v? How we touch that? Look at this question. Say this is s cubed, say this is s cubed, and say this is exponential 2x. By the time you start differentiating, meaning performing your higher derivative, one of these two, you end up having 0, right? Meaning by the time you differentiate this first time, what do you have? 3s cubed. Differentiate again, what do you have? 6x. Differentiate again, what do you have? 6. Lastly, what do you have? 0. Let's differentiate this. What do I have? 2 exponential 2x, right? 4 exponential 2x, 8 exponential 2x, 16 exponential 2x, 32 exponential 2x. Continuously, right? You observe that the fourth derivative of this, we got what? 0. We got 0. But the fourth derivative of this, we got 16 exponential 2x. Can we differentiate 0? No. But we can still differentiate the fourth derivative of this. So what it means that, given a question, identify the function that by the time you perform the higher derivative, you end up having 0. You end up what? Having 0. Meaning that particular function, you take it as v. That particular function, you take it as what? V. Meaning that particular function, you take it as v. While the other one that keeps going in a concurrent manner, meaning you keep having the higher derivative, you keep having the higher derivative, you take it as what? U. You take it as u. So meaning for this question, this is my what? This is my v, where this is my what? U. Where is my u? You know, we are doing higher derivative. The question now is, where do I stop when differentiating? Where do I stop my higher derivative? I'm going to stop my higher derivative at the fourth derivative. Why am I stopping at the fourth derivative? I'm stopping at the fourth derivative because I got 0. Meaning, when v is equals to this is the first derivative, this is the second derivative, this is the third derivative, and the fourth derivative, what do I have? I have 0. Meaning, I'm going to stop my higher derivative at the fourth time. Why am I stopping there? I'm stopping there because I got 0, right? So, similarly for this, meaning I'm stopping my higher derivative, which is the fourth derivative, at this particular derivative. Any question? No question. Now, so we are saying that given this question, my u is equals to what? Exponential 2x, right? And my v is equals to what? S cubed. Meaning I have u prime as 2 exponential 2x, right? U prime 4 exponential 2x, u raised to the power of 3, meaning the third derivative, what do I have? 8 exponential 2x, right? u raised to the power of 4, what do I have? 16 exponential 2x, right? Then what do you have here? V prime 3x squared, v prime prime 6x, right? Then v prime prime prime, what do you have? 6. Then the fourth derivative, what do you have? 0. We are stopping at this fourth derivative because we got 0 for the v function. Let's say you got 0 at the fifth derivative, meaning for u function you stop at the fifth derivative. Are you getting me? Now what it means is that for your u derivative you can generalize an n derivative for it, saying that the n derivative of your u is equals to 2 raised to the power of n exponential 2x. True or false? True. Right? Meaning, looking at what you have here, you can generalize the nth derivative of u, saying the nth derivative of u is equals to 2 raised to the power of n multiplying exponential 2x. Let's see how it works. Using that formula, say you have u raised to the power of n equals to 2 raised to the power of n multiplying exponential 2x. I want to find the first derivative, meaning u raised to the power of 1. What do I have? 2 raised to the power of 1 exponential 2x, right? I want to find the second derivative. What do I have? 2 raised to the power of 2 exponential 2x, right? I want to find the third derivative. What do I have? 2 raised to the power of 3 exponential 2x. I want to find the fourth derivative. What do I have? 2 raised to the power of 4 exponential 2x. Doing comparison with what we've done so far, are they correlating? They are correlating. So up to this level, what you are saying is that once you identify the concurrent derivative, meaning the one that you keep getting the derivative, generalize the nth derivative, meaning write out the nth derivative. So that's what we did here. Meaning the nth derivative of u is equals to 2 raised to the power of n multiplying exponential 2x. And we've seen that from this general solution, that the power of u is always in terms of what? N. The power of u is always in terms of what? N. Instead of writing the second derivative as 4 exponential 2x, I can write it as this is u prime is equals to 2 exponential 2x, right? The second derivative, instead of writing it as 4 exponential 2x, I can write it as what? 2 raised to the power of n exponential 2x, right? Where n is equals to what? 2. Instead of writing the third derivative as 8 exponential 2x, I can write it as what? 2 raised to the power of n exponential 2x. Where n is equals to what? 3. Instead of writing the fourth derivative as 16 exponential 2x, I can write it as what? I can write it as what? 2 raised to the power of n exponential 2x, right? Where n is equals to what? 4. Where n is equals to 4. Then this implies, take note that this implies that u raised to the power of n minus 1. Back to your series solution, you are having u raised to the power of n. You are having u raised to the power of n minus 1. You are having u raised to the power of n minus 2. You are having u raised to the power of n minus 3. Meaning you have to know the value of u raised to the power of n minus 1. Then substitute, right? Are you getting out of? In this case now, u raised to the power of n, you still have it as u raised to the power of n. What's your v? S cube. Meaning this substitution, this formula, I'm just inputting value. I'm just doing substitution. That's what it means. I just need to do substitution. Then I find the n derivative of this, right? In this case, let's say you want to do your substitution. Let's say you want to do your substitution now. You are saying the n derivative for this question is equals to u raised to the power of n multiplying v. What's v? S cube. S cube, right? Plus, okay, let's do it. You see what I'm saying? Meaning the nth derivative of this question, I raised to the power of n is equals to u raised to the power of n multiplying v. What's v? What's v? S cube. V is s cube. S cube, right? Plus n multiplying u raised to the power of n minus 1, right? Multiplying v prime. What's v prime? The first derivative, 3s squared, right? Plus n all into brackets n minus 1 all divided by 2, multiplying u all raised to the power of n minus 2, multiplying v square. What is v square? The second derivative. What is the second derivative? 6x, right? Plus n all into brackets n minus 1 all into brackets n minus 2 all divided by 6, right? Multiplying u all raised to the power of n minus 3, multiplying v cube. What is v cube? the third derivative, what do you have? 6. Multiplying 6. Multiplying 6, right? You know, I'm having the fourth derivative in this case. By the time you write your series solution for the fourth derivative, you know, 0 multiplying by the coefficient, you still have 0. You still have 0. So do we need to include that? We don't need that. But in this case, I'm having u raised power of n minus 1. I'm having u raised power of n minus 2 and u raised power of n minus 3. What is the value for it? I can't just leave my answer as this. I can't just leave my answer as this. Meaning, I have to know the value for u raised power of n minus 1, u raised power of n minus 2, and u raised power of n minus 3. Back to what we differentiated. If this is u raised power of 1, it implies that u raised power of n minus 1 is equals to 2 raised power of n minus 1 exponential 2x. If this is u raised power of 2, meaning the second derivative, it implies that u raised power of n minus 2 is equals to what? 2 raised power of n minus 2 exponential 2x, right? If this is the third derivative and I need u raised power of n minus 3, it means from this third derivative, what does it imply? It implies u raised power of n minus 3 is equals to 2 raised power of n minus 3 exponential 2x. This implies that u raised power of n minus 4 is equals to 2 raised power of n minus 4 exponential 2x, right? When we substitute those values here, we are asking ourselves that we need the value of u raised power of n minus 1, right? You know, this is actually correct, but I can actually solve for u raised power of n minus 1, u raised power of n minus 2, and u raised power of n minus 3, right? We are not saying that if u raised power of 1 is this, it implies that u raised power of n minus 1 is this, right? If u raised power of 2, meaning the second derivative is this, it implies this. If the third derivative is this, it implies this. If the fourth derivative is this, it implies this. So what it means is that anywhere I see u raised power of n minus 1, what do I substitute? I substitute this. What is it? Yeah, 2 raised power of n minus 1 multiplying exponential 2x. Anywhere I see this, I substitute this. Anywhere I see this, I substitute this. And lastly, anywhere I see this, I substitute this. Are you getting it? So let's substitute. Let's substitute. My nth derivative, right? Y raised power of n is equals to what? U raised power of n, u raised power of n, right? Multiplying s cubed plus n multiplying u raised power of n minus 1, right? Okay, what u raised power of n minus 1 now? Now what? All into brackets 2 raised power of n minus 1 multiplying exponential 2x, right? Yeah. Multiplying, what do I have here? Multiplying 3x squared, right? Yeah. Plus, the next one is what? N all into brackets n minus 1, all divided by what? 2, multiplying, what was u raised power of n minus 2? I have 2 raised power of n minus 2 multiplying exponential 2x multiplying 6x, right? Yeah. Plus the next one, n all into brackets n minus 1 multiplying n minus 2 all divided by 6. U raised power of n minus 3 is what? 2 raised power of what? N minus 3 multiplying exponential 2x multiplying what? 6. Right? From this substitution that we've done so far, any question? Do you have any question from this substitution that we've done so far? You know, this is the general solution for the n derivative. Then we've substituted all what we've gotten so far. U raised power of n as this. This is it. Multiplying b, meaning the function of b. This is it, right? Plus n. This is the n. Multiplying u raised power of n minus 1. This is u raised power of n minus 1. So we've subtracted all of these functions, right? We now said from here, what we want to do is that we want to factorize. From what I have here, I want to factorize. Being factorizing, meaning I'm going to observe the common functions, then I bring it out. I'm going to bracket what I'm left with, right? But take note that u raised to the power of n. You know, in this case, I'm having 2 raised to the power of n, 2 raised to the power of n minus 1, 2 raised to the power of n minus 2, 2 raised to the power of n minus 3. So I'm going to write this in a way such that all value of 2 will be having the same power. Are you getting it? Looking at this, let's say we want to factorize. What's common between all these functions? What's common? Exponential 2x, right? Exponential 2x. Are you getting it? Exponential 2x is common. But at the same time, what if I write 2 raised power of n as 2 raised power of n minus 3? I write 2 raised power of n minus 1 as 2 raised power of n minus 3. And I'm also writing 2 raised power of n minus 2 as 2 raised power of n minus 3. So it means that both exponential 2x and 2 raised power of n minus 3 are common, right? Meaning I factorize. Are you getting me? I get what I'm saying? From what I have here, I want to factorize. I can see that exponential 2x is common, meaning I can factorize, right? But at the same time, just to have a nicer equation or a better equation, I can make 2 raised power of n, meaning the function of 2. I can make the function of 2 having the same power. Meaning I can make the function of 2 to have the same power, right? I'm having 2 raised power of n. 2 raised power of n minus 1, 2 raised power of n minus 2, 2 raised power of n minus 3. So it is my choice. Do I want all the function of 2 to have the same power as 2 raised power of n, or 2 raised power of n minus 1, or 2 raised power of n minus 2, or 2 raised power of n minus 3? Are you getting me? So you can choose any of this power, but I'm using 2 raised power of n minus 3. So I'm expressing all function of 2 as 2 raised power of n minus 3. Meaning 2 raised power of n is 3 times as you writing 2 raised power of n minus 3 times 2 raised power of 3, right? By indices, this is correct. By indices, 2 raised power of n is equals to 2 raised power of n minus 3 times 2 raised power of 3. Meaning n minus 3 plus 3. This is what? 0. You still have this, right? Similarly, 2 raised power of n minus 1 is 3 times as you writing 2 raised power of n minus 3 multiplying 2 raised power of 2. Following indices, it becomes 2 raised power of n minus 3 plus 2. Minus 3 plus 2, what do you have? Negative 1, meaning n minus 1, which is this. Likewise, the last one, which is 2 raised power of n minus 2. It becomes 2 raised power of n minus 3 multiplying 2 raised power of 1. By indices, I have 2 raised power of n minus 3 plus 1. Negative 3 plus 1, what do you have? Negative 2. So, what I've just done here is that I express all function of 2 in such a way that 2 is having the same power, right? Meaning 2 is having the same power. And what is the power in this case? 2 raised power of n minus 3. So it means that I can factor out both exponential 2x and 2 raised power of n minus 3, right? So with what I add here, this substitution, it becomes what? I'm having y raised power of n is equals to, in this case, we've expressed 2 raised power of n as what? 2 raised power of n plus 3, right? Following what we did here. Anywhere I see 2 raised power of n, what do I substitute? 2 raised power of n minus 3 times 2 raised power of 3. So it becomes what? I'm still writing all of this, right? But in this case, I'm seeing 2 raised power of n. Following this, we said this is 2 raised power of n. It becomes what? 2 raised power of n minus 3 multiplying 2 raised power of 3. What's 2 raised power of 3? 8. So I'm having what? 8 multiplying what? 8 multiplying s cube, right? Any question? Okay, let me write 8s cube exponential 2x multiplying 8s cube, right? Any question? Moving on, what do I have? I'm saying this, right? I'm saying n all into bracket 2 raised power of n minus 1. What's 2 raised power of n minus 1? I can substitute 2 raised power of n minus 1 as this, right? Right? So let's substitute. What do I have? I have 2 raised power of n minus 3, right? Times 2 raised power of 2. What's 2 raised power of 2? 4. So I'm saying 4 multiplying exponential 2x all into bracket 3 exponential 3x squared, right? Plus the next one is what? In this case, 2 cancel out. 2 go here 1, 2 go here 3, right? Yeah. So you are left with 3x. Any question on that? Similarly for this, 6 cancel out. 6 cancel out. So meaning I have plus n all into brackets n minus 1. Open a big bracket. You are saying what? 2 raised power of n minus 2. What's 2 raised power of n minus 2? What's 2 raised power of n minus 2? 2 raised power of n minus 3 times 2, right? Substitute. So you have 2 raised power of n minus 3 times what? Times 2. multiplying exponential 2x all into bracket 3x. Any question? Do you have any question? Plus the last one, what do you have? N all into bracket n minus 1 all into bracket n minus 2 all into bracket 2 raised to the power of n minus 3 exponential what? 2x. Exponential 2x. Now looking at this equation, what is common? 2 raised to the power of n minus 3 and exponential 2x is common, right? Meaning factorize, right? By the time you factorize, you then have y raised to the power of n is equals to what? 2 raised to the power of n minus 3 exponential 2x all into bracket. This first one, I'll be left with what? By the time you factorize this, you'll be left with what? 8x cubed. So you are saying 8x cubed plus, similarly to this, by the time you factorize this, you'll be left with what?
4.
You'll be left with 4n. 4n. I'll be left with 12n x squared, right? By the time you factorize 2 raised to the power of n minus 3 and exponential 2x, you know I'm having this n multiplying this 4 multiplying 3x squared, right? It becomes what? 12n x squared. So let's write that. I'm having 12n x squared, right? Moving on, what do you have? N all into bracket n minus 1, right? Multiplying 6x. Multiplying 6x. By the time you factorize this, you'll be left with this for this third term. Lastly, I'm having what? Plus n all into bracket n minus 1 multiplying what? n minus what? n minus 2. So this is the nth derivative. Alright, now what we did here is that we factorize 2 raised to the power of n minus 3 and exponential 2x, right? So by factorization, we are saying this is common. I'm having, this is the first term, this is the second term, this is the third term, and lastly, this is the fourth term. For this first term, by the time you bring out this, you'll be left with what? 8x cubed. This is it, right? Plus this second term, by the time you bring out this, you'll be left with what? N multiplying 4 multiplying 3x cubed. It becomes what? 12n squared. This is it. Plus the third term, by the time you bring this guy out, you'll be left with what? N multiplying this, right? Multiplying 2 multiplying 3x, meaning 6x. Plus this last term, by the time you bring this out, or by the time you factor out this, you'll be left with this plus this. So that's how we got it. So we are saying that given y is equals to x cubed multiplying exponential 2x. This is the nth derivative. This is the nth derivative. The difference between nth derivative and the usual derivative I know is that for nth derivative, my answer, which is the derivative of the nth term, I'm having the expression of n in it. Are you getting me? You know, by nth derivative, what are we doing? We are doing higher differentiation, meaning higher derivative. Differentiate the first time, the second time, the third time, the fourth time, and continuously, right? But the difference is that your answer, meaning what you get at the end, is in terms of what? N. You are expressing it in terms of what? N. So that's how it works. So to recall all what we've done, we said given a question, identify your U and identify your V. Or first thing first, write out the general series solution for the n derivative of a product tree, right? Once you've done that, the next thing is identify your U, identify your V. When we say identify your U, identify your V, we are saying that the higher derivative, meaning by the time you keep differentiating and you get 0, it becomes what? V, right? And the other function, by the time you keep differentiating, meaning you're having concurrent derivative, it becomes what? It becomes U. Meaning in that case, you have that as the U function and the other as the what? V function. So this is how nth derivative works. This is how nth derivative works. But let's say you are given this. Say you are given, the question says that find the nth derivative when W is equals to y raised to the power of this and s squared. You know, the way you found the nth derivative of this particular question is going to be different from this. The way you found the nth derivative of the first question is going to be different from this. You know, we said first thing first, write out the series solution, right? Write out the series solution, right? You know, by series solution, we are saying that the nth derivative of your u multiplying the function of your v, right, plus your u is decreasing, multiplying the first derivative, plus your u keeps decreasing, multiplying the what? Second derivative up to the last function. But in this case, say you are giving this question, says that find the nth derivative. What will be your u, what will be your v? This is the same idea. What's your u, what's your v?
U is
U is what? Y prime prime. V is what? S squared. Why is V S squared? Because by the time you perform your higher derivative, you end up having 0. And we've seen from the general solution that V is increasing, meaning I'm having V plus V raised power of 1 plus V raised power of 2. So this is how nth derivative works. This is how nth derivative works.